Hi everyone, welcome back to Spratt STEM Academy. Today we're going to be talking about how to calculate a formal charge on a molecule, and we're going to be using Lewis structures to kind of help us visualize these calculations. So first, I want to talk about the periodic table. One thing to note, I want us to talk about the groups on the periodic table. These are going to be your columns of elements. So in group one, which is referring to all of these elements, that means that since it's group one, it wants one valence electron on its outer shell, and that's noted by this one up here. And so all the way across, it's actually going to tell you the group number is going to correspond to how many valence electrons that the elements in that group want in their outer shell. And this is going to be very important for our formal charge calculation. So let's actually talk about the kind of formal charge calculation formula that I have that makes this really easy. My formula is formal charge, and I'm just going to write FC equals what the element wants. So I'm going to write wants minus, and then this is what it actually has. So how many valence electrons it actually has. And this value is going to be what kind of varies for each molecule. So to note, the wants is going to be the number of valence electrons we get from the periodic table. So this we find on the periodic table. But the has section, this is what we are actually going to count ourselves from our structures. Okay, so let's start with the molecule. Let's start with NO3 minus. So if I draw the Lewis structure out for this, it looks something like this. We have an oxygen double bonded to a nitrogen, and then two single bonds to two oxygens. Draw our lone pairs because we want to satisfy octet. Okay, octet is satisfied, we are all good. But let's calculate the formal charges on each element. So that means we have to calculate the formal charge on this oxygen, this nitrogen, and then the rest of the oxygens. Okay, so we'll start with the oxygen. Let's start with this top oxygen. Now our formula is want minus has. And remember, the want is the number of valence electrons that oxygen wants. And we get this from the periodic table. So let's go back up there. We're dealing with oxygen. So we look for oxygen and we see that it's in group 16, which is right here. And if we look at this number 16, this is going to tell us that oxygen wants 6 valence electrons in its outer shells. Not 16, don't let that confuse you. Basically, instead of 13, think of 3. Instead of 14, think of 4, 5, 6, 7, and 8, and so on. So oxygen wants 6. And so the oxygen's want is 6, and then what it has. So this is the tricky part. We have to count how many electrons we see here. So each lone pair, think of pair, that means 2. So this is 2, this is another 2, this is another 2. And then we have to also account for the electrons that are being shared in this bond. So since this isn't a lone pair and it's actually being bonded to nitrogen, this is actually only 1 electron here because the other electron is being shared by the nitrogen. So whenever you see a bond and it's not a lone pair, it's only 1, it's not 2. So we have 2 plus 2 plus 1 plus 2, which is 7. And then that is going to give us the formal charge on that specific oxygen. So 6 minus 7 is -1. And so I'm just going to erase all these. The formal charge on this oxygen is -1. And I'm just going to leave this as a negative sign. I hope that makes sense. Let's do the same thing for this oxygen over here. So we're going to write our formula. FC equals W minus H. It wants 6, and I know this just by looking at the periodic table. And it has 2, 4, and then each one of these bonds is 1 electron. So that's 1, 2. So it has 2 plus 2 plus 1 plus 2, which is exactly 6. So the formal charge on this oxygen right here is actually 0. So it is neutral. So we don't have to write a plus or a minus or anything like that. So I'm just going to go on ahead and write the same as this oxygen up here. So now let's do our formal charge calculation for our nitrogen. So nitrogen, if we look at our periodic table, it's in group 15. So that means that it wants 5 valence electrons in its outer shell. So let's go back here. This nitrogen doesn't have any lone pairs. It has 4 bonds, which is a good thing. But remember, one bond is 1 electron. So we have 1, 2, 3, 4. Let's write out our formula. It wants 5. So we write 5, and it has 4. So the formal charge is a positive 1. And so this nitrogen gets a plus sign. Okay, so we've accounted for each element's formal charge. Now, in order to make sure that we've calculated them all correctly, we have to add them all together, combine them all, and make sure that they add up to what the charge on the original compound element was. So this was our original compound, NO3 minus. We need to make sure that when we combine all of our formal charges, they get us to -1. So a -1 plus a +1 plus another -1, that gives us -1 because -1 plus 1 is 0. So we're left with just -1, which is exactly what we have up here. And so that's how we know that we've calculated all of our formal charges on each element correctly. I hope this made sense and I hope you enjoyed. Don't forget to like, comment, and subscribe for more.